Hello everyone, welcome to this channel. So today we are going to dive into our first project in machine learning. And then the data that we are going to analyze is the Titanic Dataset. Amazing. So that is our first project here. So these are the steps that you are going to, take in this video tutorial. First, you look at importing the necessary libraries, loading data sets, exploring the data set, visualizing it, outliers detection, data cleaning, and then finally we come to the final data set. So when we come to where we are going to import our libraries, let's look at how to import our necessary libraries for this project. Good. So these are the necessary libraries that we need to import. Mass, SciPy, NumPy, Pandas, and then Seaborn, Data, MATLAB plots, and then what have you. So each of the libraries have got its own task that is going to perform. So after this, we just run this one. Okay. So after tapping around, you see that this side has turned into something like amount, this means that it is processing. So after that, when it is done, you see that it turns back to this one. Then it means that it has finished execution. Let's move on to the second one. But so before we can, open our data set, we need to load the data set in our Jupyter notebook. Okay. So in loading our data set, you have to create a variable, CTF. So the variable TF is storing our, data set. So the R represents read, and then this one is the path or the file location of my data set. So this is the name of my computer, that's the greatest computers. And then on desktop, I have created a folder. Within the folder is where I have, stored my data set. The name of my data set is string.csv. The meaning of CSV is comma separated values. Then also I have to also run this one here. So after running this one, I need to visualize my data. So visualizing the data, we use dot head. Okay, so we have TF. So TF, the name of our variable that has stored our data. TF dot head. Sorry, TF dot head. TF dot head. So let's run this one. So after clicking that, you have seen the general overview of our data set. So this is a comma separated data set. We have passenger ID, the columns here, and then that of what the row. So the dot head will give you the general overview of your data set from 5 samples or 5 views. So that is what the dot head is doing. You can specify the number of views that you want to see by inputting maybe a number inside. Let's say 20. So in this one, 20 means that's going to give us first 20 views of our data. Let's see that. I'll see that it has given us the first 20 starting from 0 to 19. Okay. So that is how the dot head works. So let me go for the default one that is first 5. Okay, good. So we also have the one that we call the dot tail. The dot tail will also give you the last 5 rows of the data. So let's see tf dot tail. So tf dot tail. That one too. Good. So as you can see, the dot tail has given us the last 5 rows of our data set. All right. So we come to data exploration or exploring the data set. So here you are going to consider three steps. The first one is going to be the checking of the data types. Then you come to the checking the shape, that is the rows and that of the column, and the last one is the describing the data. So let's look at how to check for the data types. So let's comment using the hashtag checking for the data types. Okay, so data types. Then we come here. So data types, use d types. So tf dot d types. Okay. Then we run this one. So So it will give us the data types of each column. So passenger ID, so there's a what an integer data type, survive, integer, we have name, object. So object data type can also be classified as a qualitative or a categorical data types. Then we have floating points. So these are the data types that we have. Then also we go and then we look at the shape of what our data, the use and that of what the columns. So let's check in for the shape of our data, our data set, shape of our data set. So the shape of our data set we use dot here. So tf dot shape, tf dot shape. Yeah, so this is the shape of our data. It has 891 use and then 12 what columns. Okay, so the first one represents the use and the last one represents what the columns. So it has gotten 891 use and then 12 what columns. So let's see the last one, which is the describing what the data or statistical summary. So that one use what describe. So we have tf dot describe, tf dot describe. I have parentheses here. Yes, dot describe. So the describe will give you the statistical summary. That is the count, the mean, the standard deviation, and then what have you. So it will take each column and then summarize it by counting it, find the mean, and then finding the standard deviation. So you come to the fourth section, that is visualization. We're going to visualize our data. So as I said earlier, the data set, we have gotten types of data in the data set. So we have categorical or qualitative and then quantitative or numerical data set. So the categorical data set include the objects that we saw, and then quantitative or the numerical data set include the integer values and that of the floating data point. So first we look at the numerical data set. Okay, so let's look at this code. So this code is used to create a histogram to visualize numerical data what types. So let's run this one and see the results. Good. So the numerical data types has been visualized using the histogram. So histogram plot has been plotted here. So this is the passenger ID. This one is the frequency, and then this one is the column against the frequency. So this one is the histogram for visualizing the numerical data set. Okay. All right. So let's look at how to also visualize the categorical data set or the object data types. So here, this is the code for visualizing that one as well. So that one we're going to use count plot to visualize that one. So we run this one over here to observe that one as well. So you use while the ID, this is our input commands to give us the results that we expect. All right. Okay, so this is our output from our ID. So this one is the count plot of what names. So the name is what object data type. So categorical data types. So we have count plot of sex. So we have male and female. You can see that there were more males than what females on board. And then this one is the count plot of tickets, and then this one is the count plot of the cabin. So the cabin is the deck that each passenger was found, and then the count plot of embark where they took the ship from. Okay, all right. So we come to the outlier detection. So outliers are extreme values that are found in data sets such that they are extremely different from the common data set values that we see. Okay, if you are going to look at these outliers here, so these are the codes that are used to, visualize the outliers in our data set using the box plot. So you create a box plot and then use to visualize I mean, the outliers in each of our columns that are found in our data set. Okay, so here you are going to run this one over here, and then our box plot has been created for us for each of our columns in the data. So this one is the box plot of the passenger ID. There is no outliers. This one, so there is no outliers, no outliers. But here, plot of age, see that there are some outliers that have been created here. So this was small circles that you see here are the introduction of what outliers in our data sets. Okay, so this one, so there's outliers there. So the outliers, this one, you see that these outliers, some of them are close to each other, and some of them are wide apart. So outliers, as I said, they are extremely large values that are found in the common values in our data set. So, for instance, let's say we have a range of values in the form of accounting numbers ranging from, let's say, 1 to 10, and then as we are having all these numbers, then you can just see a very huge number like 53, 70, 80. So 53, 70, 80 are outliers because they are not within a common range from 1 towards 10, as we specified from the beginning. Okay, so here, outliers here. Here to there is an outlier. This one to a lot of outliers over here. So this one is used to just visualize that the outliers over. All right, so here we come to point six. Point six is where a lot of uh, work is going to be done in our data set. We are going to make changes to our data sets. So here is where we start our data cleaning to prepare the data for the next level of our analysis. So first we have to check for null or empty species in our data set. So this one we are going to check for values or missing values with percentage. So we are creating a variable called missing count. So the missing count uses the dot is now and then dot sum to check for what the missing values and then express it in what percentage. Okay, so we are going to express it in percentage. Let's add percentage sign to this one and see. And then express it in percentage. Sorry. Okay, so this one is giving us some error because of the percentage sign. Okay, so this is the summary of the missing values. So here, if you see 00 means that there are no missing values in that form. But if you see non-zero number, it means that there is what a missing values in that what column. So 8 is having a missing value with a percentage of 19.865 percentage. Then come to the carbon. The carbon too is having a missing value with a percentage of 77, very huge. And then the embark is also having a missing value with a percentage of 0.2. This is actually very small, very, very small. So under this one, you're going to also look at how to handle missing values. So the missing values you can see from the columns that we have age, the carbon, and that of what the embark. Those side are having what missing values from here. So age, carbon, and then what's the ember. These are the parts that are having missing values. So how do you treat the missing values? So let's look at how to treat the missing values. So the missing values, we have missing values in either categorical data type or numerical data type. So if it is a numerical data type, we are going to replace it by the mean or the median. And if it is categorical data type, we only equate it by the mode. Okay, the one that appears the most. So let's see this goes here to check for the age. You visualize the age and then see whether we are going to replace it with the mean or what the median. All right. Okay. So this is the display of our course. So the age. This here is the age. Okay. There is the age distribution, and then the age bus plots. These are the outliers in the age bus plots. So we are going to compare the mean and what's the median. So the mean is 29 years, 29 years, and then the median is 28 years. The skewness, so the skewness also relates to the outliers in our data set. So I have already explained the outliers. So when we look at the skewness, The skewness is 0.39, which is relatively what small, and then the difference is what 1.78. So, in conclusion, the skewness is relatively small, approximately what normal. So, we have normal what distribution and other distribution that we talk about in our subsequent videos. So, with this one, we are going to what accept the mean to use to replace what the missing values in our what categorical, sorry, our numerical data. So, oh yeah, our categorical what data set. Okay, so we are going to use that one to replace the missing values there. All right, so let's move on to our next column, which is also having a missing value, and that one too. We are going to use this code to address that one. Okay, so we are handling missing values in the carbon what inside or column. So this one, you are going to look at how to deal with that one. So you can see that the carbon values that were missing was extremely very high because this was covering a percentage around 70 something. Yeah, 77.1 percentage. Okay, so this one is really, really high missing with value. So that column is having a very high missing value. So because of that, that is, I mean, the missing carbon value is 687 out of 891. So it is very high. So decision, you are going to what, drop that column. So dropping that column means that you are going to what, remove that column. So you have removed the column of the carbon. If you try to, I mean, replace them with the mode, it's going to introduce, I mean, overfitting in our data sets, which will not help in decision making and then building of our model. So the last missing value was found in the embark. So the embark too, it was also very small. The embark too was very small. So handling missing embark was values. So these are the clues that you check how many are missing. Okay, so let's run this code and see. So the missing and back values, there are only two missing and back values. Missing and back values now is zero because we have what dropped that one. So we have removed two rows from our data set because it was only, I mean, two missing values. So we just, I mean, we can just, I mean, remove it. Okay, we can just remove it. Or better still, we can also replace it with different, I mean, uh, 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 measure of dispersion. Okay, so we have just removed that one. Okay, but you can also go ahead to replace it with either the mean because this one is a categorical data what type.